Hello everyone, today we are going to start chapter number 6, that is lines and angles. You are quite familiar with the term lines and angles too. We just do the concept today, basic terms and definitions. Okay, here you know that this is AB. When we have only this on it, it means AB is an exact line and its length will be given. It is a line segment, right? And if we have given both side arrows on this, you know this is the notation of a line. It means it is a endless length, means here length we have not properly given. And if we have given like this AB and this ray on it, it means AB is a ray, means one side is fixed and another is open, so it can be produced from one side. So you are familiar with these three terms: line segment, line and ray. Now collinear points are the points that lies on the same line segment or a line. Collinear points. So collinear points are the points that are lies on the same line segment, and if they are not lies on the same line, then they are non-collinear. Vertex, you know that the point where two rays meet is vertex. This point is vertex, and measurement between these two arms is angle. So there is a difference between angle and a vertex. If I'm writing if I'm drawing like this is A and this is 30 degree, so A is vertex and 30 is angle, right? So this is the difference. And arms, you know that these rays are called arms. This is arm of the angle, this is arm of the angle, right? If a acute angle you are taking, means it lies between 0 to 90, right angle exactly 90 degree, obtuse angle more than 90 and less than 180 degree, and an angle that is of full 180 degree is called straight angle. And a reflex angle is if you are having here 30 degree, then 360 minus 30 is the reflex angle, right? This one is the reflex angle. So it can lies between 180 and 360, 180 and 360, right? So it is more than it lies between 180 and 360. Now come to the next one. What are the adjacent angles? If two angles share a common arm, if these two angles 1 and 2 share a common arm, this is the common arm for these two angles, and the measurements are different, means it may be angle 1 or 2 equal or not equal, but their measurements are means they take separate spaces, and they share a common arm. These are two adjacent angles. So angle 1 and angle 2 are adjacent angles, right? Now you know linear pair. When you have a line segment and two angles are made on it, 1 and 2 are linear pair. If you add 1 and 2, you will get 180 degree. This is the linear pair, right? In the 7th class also you have studied about this. Now come to vertically opposite angles. You know that vertically, if two line segments cross each other, means intersect each other, and you get some angles here, this angle and this angle are equal because they are vertically opposite, and this angle and this angle are equal because they are vertically opposite, right? So next one is intersecting lines. If two line segments cross each other at an angle, these are intersecting lines. They just have one intersection point. Parallel lines that are not having any intersection point, but the length, the distance at every instant will be same. If it is 3 centimeter, 3 centimeter will be here. Okay, so non-intersecting lines are parallel lines. You can say that parallel lines never meets, and the best example is your railway tracks. They never meet but they are parallel always. They are always parallel, you know, they are always parallel. So intersecting lines intersect at one point, and non-intersecting points will never intersect any point. And now pair of angles. So pair of angles are the same thing, that is, if angle 1 and 2 are drawn on the same line with this ray, these are pair of angles, right? So their sum will be 180 degree, because this is lines, AB is the line segment on, and it is a straight angle. This is the straight angle, and straight angle is of 180 degree. How many parts you can do here? In the pair, you know that two angles are there. So angle 1 and 2, when you add angle 1 and 2, you will get 180 degree. This is the pair of angles. Now come to first exam here. The first exam will be used only as the statement. If the ray stands on a line, then the sum of two adjacent angles formed is 180 degree. If a ray formed on a line, this is the ray standing on the line, this is the line that we are talking about, and this is the ray that is standing on this line, then the sum of two angles, angle 1 and 2, will be 180 degree. And you know that this is straight angle. I told you these are linear pairs. So angle 1 plus angle 2 is always 180 degree, right? You will use this exam. And here are some examples. Say 30, and you have to tell whether they are linear pair or not. If you add 30 and 60, you will get 90. So these are not the angles, and this is not the ray. This is not the ray for the line. So you can say that this AB is not a line. Okay, AB is not a line. So come to next one. If you add 80 and 60, you will have 140. So it must be 180 if it is a line. So AB is not a line, right? Now come to the next one. Here you have given 55 and 125. So add 125 and 55. How much you get? 5, 5, 10, 7 and 1, 8, 180 degree. So yes, you can say that this AB is a line, and this OC is the ray stand on this line AB. Now come to the next part. You have given 150 and 70. If you add them, you will get 220, right? So this is very more than 180 degree. If it is more than, then what you say? This AB is not a line. As you see, this is not a line, and yes, it is ray, but this is not a line. So come to exam number 2 here. This is your exam number 2. See, the sum of two adjacent angles is 180 degree. Then the known common arms of the angles form a line. Okay, if you take this one, I'm taking, and I'm taking two adjacent angles, right? Angle 1 and angle 2. So this is common arm, because A and B are adjacent. So this is common arm, and these are two known common arms, right? I'm taking A, B and C, right? This is O point. So these are known common arms, OA and OC. Now if you add these two angles, this 1 and 2, you will get completely 180 degree. If you add these two, you will get 180 degree, right? So if it is 180 degree, so what you can say? The known common arm is a straight angle, and a straight angle is of 180 degree, you know that. So what the given thing is here, what we have to show here is the sum of two adjacent angle is 180. If we have taken angle 1 and angle 2, sum is 180 degree. The known common arms, that is OA, that, let me again, this is A, O, C, okay, this is B I have taken. So this is angle 1 and 2. So known common arms, this is OA, and the angle with the known common arms, that is angle 1 with the OA and angle 2 with OC. These two angles, so this form a line. So yes, AC is a line. Now come to the theorem. If two lines intersect each other, then the vertically opposite angles are equal. Okay, we have to prove here, if these are intersecting lines, then this angle 1 and 2 are equal, and 3 and 4 are equal. So let us start. here what we can do. See here, this O is the intersection point, and AOC and BOD, we can take AOC and BOD, these two angles, and we have to prove this, these are equal, AOD equal to BOC, that we have to prove here. So let us take, if I am taking this line segment, AOC plus AOD, this is equal to 180 degree. I am taking 1, 2 here, 3 and 4 here. So angle 1 plus angle 2 equal to 180 degree, right? And from this line segment, you know, this is angle 1 and 4, angle 1 plus angle 4 equal to 180 degree. In both the conditions, you see the right hand side is same, so left hand side must be same. So you can write angle 1 plus angle 2 equal to angle 1 plus angle 4, right? So both side we have angle 1 with the same sign, so you can cut here. So we get angle 2 equal to angle 4. So angle 2 and 4 are vertically opposite angles, and we have showed they are equal, right? Similarly, you can use here, if I am taking this line segment, I am writing here 1, 2, 3, 4. So angle 1, this is 3, and we are taking angle 1 plus angle 2 equal to 180 degree, and here also angle 2 plus angle 3 is, angle 2 plus angle 3 is also 180 degree. See, this is line and this is a ray, so angle 2 plus angle 3 equal to 180 degree. Now you see both the right hand sides are 180 degree, and so they are equal. So we can put angle 1 plus angle 2 equal to angle 2 plus angle 3, both are equal. Now see, the same sign angle will cut both the sides because equality is there. So angle 1 equal to angle 3 we get from here. So this angle 1 equal to angle 3 we have proved, right? So it is quite easy to show that the opposite angles are equal. In this theoretical part is given, you can use the name of angle 1, 2, 3, 4 also. It will be quite easy. Now come to example number 1. So what is the first example we have given here? In the figure 6.9, the line PQ and RS are intersecting. You see they are intersecting each other at point O. Angle POR, this is angle POR, this angle 1 I am taking, this is POR. Ratio angle ROQ, this is ROQ, angle number 2 I am taking here. The ratio we have given is 5:7. So find the other angles. So you know that we have given the ratio of these two angles, and also we have the relation that PQ is the line and OR is the ray. This OR is ray and PQ is the line. So 1 plus 2 must be equal to 180 degree. So we have here taken POR and ROQ, or you can write angle 1 plus angle 2 equal to 180 degrees, the same thing. Now we have given the ratio that it is 5:7, right? And here angle POR we can find from here equal to 5/12 of 180 degree, right? 5/12 how can we find? Because in the ratio we have given 5:7. Sum of the ratio is 5 plus 7, that is equal to 12. So part of the angle POR is 5/12 into 180 degree, right? And part of ROQ is 7/12 into 180 degree. So it is very easy to understand for you because you have done this ratio and proportion chapter. So we just find the part of this angle POR by using sum of the ratios. So 5 by 5 plus 7 is 12 into 180 degree. Why I am writing this in 180 degree? Because this is not the angle and we have to convert the number into angle by multiplying 180 degree. So you get after the reduction, cut it, 12 ones are 12, 12 5s are 16, 15 5s are 75 degree. So this angle is POR 75 degree, right? After getting the one angle, you can find the other angles also. So this is you know that this is 7, this is fifth part of the angle, this is 7 part of the angle. So you can find 7 by sum of these two is 12, 7 plus 5 is 12 into 180 degree. This is I'm finding this angle number 2. So cut it. 12 ones are 12, 12 fives are 15, 7s is 105 degree. So we get 105 degree here. So I hope you get. This one is fifth part of the 12 into 180 degree, and this is 7 part of 12 into 180 degree. I'm just converting into degree. So this I got 75 degree, and this we got 105 degree. So the opposite angle of this one is again equal, because opposite angles are equal, so 75, and opposite angle of this one is 105 degree. So you got all the angles. So I hope you understand this method. Now come to example number 2. Here we have given in the figure OS stands on a line. This is OS, a ray, and on a line OPR, okay. OR and ray OT are the angle bisector of, okay, these are bisector. It is given that they are equal. This angle is equal to this angle, means angle POR equal to angle ROS, and similarly angle SOT equal to angle TOQ. So you are quite familiar with the sign that are put on the angles here. So we have given that bisector of the angles, and if POS is X, I'm taking POS, this wall angle is X. This wall angle is X, means half of here is POR and half of X is ROS, right? So what we have to find? ROT. So this is your angle ROT. This is ROT that we have to find, right? So let us start. I'm taking this POS and SOQ. This is POS and SOQ. POS and SOQ. So if we have given this OS is the ray and this is the line segment, so that you can find this angle POS and this angle SOQ. If I'm taking 1 and 2, the sum will be 180 degree. So sum will be 180 degree. So here it is given sum is 180 degree. Also POS we have given X. We have given POS is X. So value of POS is X. You can find this angle, this SOQ, by transposing X to the right hand side, and it will become 180 minus X, right? Now OR is the bisector of POS. I told you this angle is half of X. If this whole angle is X, this angle is half of X, and this is also half of X. This angle is also half of X. So these are X by 2 and X by 2, right? Now similarly we can find from here, this is SOT, the angle SOT we have. This is angle SOT, this angle. So this is also a half of SOQ, and SOQ we have find here is 180 minus X. So angle SOT, angle SOT will be half of 180 degree minus X. Got my point? So this is half of 180 minus X. So what it SOT is, this is half of SQT. So this is if you solve this 1 by 2, this is 180 by 2 minus X by 2. You can cut here 90. So this is 90 minus X by 2 SOT, right? Now we know that ROT is the sum of ROS and SOT. This is ROT. Let me show you in the figure. This is ROT. This is your ROT. This is sum of SOT and ROS and SOT. ROS is X by 2, right? And SOT is that I solved 90 minus X by 2. So X by 2 to X by 2 cancel. You will get 90 degree. So the required angle is 90 degree, right? Now come to example number 3. So in the example number 3, I'm sorry, this is not working. Example number 3, OP, OQR and OS are the rays. Prove that angle POQ, angle QOR, angle SOR and angle POS equal to 360 degree, right? So here if we assume that that OQ TOQ is the line, let us assume, I'm just assuming TOQ is the line and OQ is the ray, then this angle 1 and 2 when added you will get 180 degree. So your two TOQ and QO and your POQ, this is your POQ and okay, we will cover this one in the paper pen video, right? It is lengthy to understand why this video, right? So complete today the concept and the examples.